Okay, this question has to find an equation for a sphere with center of 0, -8, -5, and radius of 8. Okay, let's write it. So since we're given the center is 0, -8, -5, this can be written as x squared plus y minus 8 squared plus c minus 5 squared is equal to radius squared 8 squared, so 64. So if you write it, this becomes x squared plus y plus 8 squared plus c plus 5 squared. But since the answer choices are the standard form, are not in the actual radius like point form, so you have to put it as, you have to expand it basically. So this becomes x squared plus y squared plus 16y plus 64 plus c squared plus 10z plus 25 is equal to 64. 64 canceled out. So this becomes x squared plus y squared. I'm going to put the c squared front. C squared plus 16y plus 10z is equal to -25. Let's look at the option that's the same. So x squared plus y squared plus c squared plus 16y. So a, b can work. It's not c, d. E can work. And then it's 10z plus 10z. So b is not right. So it's going to be either a or e. Oh, but yeah, I just noticed it's not 8c squared, it's c squared. So e is not right. So the answer is a. The question says if b is equal to x2 and w is equal to 1x, find a positive x such that b plus w magnitude is equal to square root of 61. Okay, so b plus w, let's find that first. B plus w is x2 plus 1x, which is x plus 1 and 2 plus x. That's a comma, that's a giant comma. I'm gonna fix it. Okay, there we go. X plus 1, comma 2 plus x. And yeah, I'm gonna put it there because my screen froze again. So now, if you want to find the magnitude, you do b plus w magnitude, which is square root of x plus 1 squared plus 2 plus x squared, which becomes x squared plus 2x plus 1 plus x squared plus 4x plus 4, which is same as the square root of 61. And this is, if you simplify this becomes 2x squared plus 6x plus 5 is equal to square root of 61. Square both sides, 2x squared plus 6x plus 5 is equal to 61. 2x squared plus 6x minus 56 is equal to 0. Divide by 2, x squared plus 3x minus 28 is equal to 0. X plus 7, x minus 4 is equal to 0. X is equal to -7 and 4. But we are given that find a positive x, so that becomes x equals 4. So the answer is A. Okay, this question asks to find the volume of the solid obtained by revolving the region in the first quadrant bounded by y equals 2 over x and y equals 2 around the y-axis. Let's draw it. Y equals 2 over x in the first quadrant, so this line, something like that. And then x equals 2, y equals 2. Okay, and this point would be x equals 1. This point would be, since we are plugging in x equals 2 in the y equals 2 over x, y equals 2 over 2, which is 1. So this line is y equals 1. I calculate this line because we're interested in this region. Okay, so if you draw your line, I'm going to use the disc washer method. So this is, which is vertical to the axis, which is this line, y-axis. So it's going to be looking like this line. So we want to find that line, that length, which we know that the disc washer method use b equals to pi, bigger radius squared minus smaller radius squared, right? So in our case, it's going to be the horizontal line, so it's going to be dy. So our bigger radius is this line, which is y equals 2. So 2 squared minus smaller radius, which is this line, which I can make in a different color, this line, smaller radius, which is y equals 2 over x, but it's not exactly y equals 2 over x, but we have to write it into x equals something with respect to x basically, because it's the horizontal line. So y equals 2 over x is same as x equals 2 over y. So this becomes 2 over y squared, entire thing dy, integrating from 1 to 2. So if I rewrite it, pi 1 to 2, 4 minus 4 over y squared dy. So this becomes pi 1 to 2, 4 minus 4y minus 2 dy. And if you integrate it, this is 4y minus plus 4y minus 1 from 1 to 2 times pi. So pi 8 plus 2 minus 4 minus 4. This 8, negative 4, 8 cancelled out, so this just becomes 2 pi. So the answer for this question is D. Okay, this question asks to find a vector that is perpendicular to the plane which contains points P1, 2, 3, Q, 3, 1, negative 1, and R, 3, 3, 1. So let's draw a plane. Okay, P, 1, 2, 3, Q, 3, 1, negative 1, R is 3, 3, 1. Okay, so PQ is gonna be 2, negative 1, negative 4, sorry. And why is it like that? I don't know. PR is equal to 2, 1, negative 2. Okay. Yeah, I don't know why there's a white space in between, and I don't know what's wrong with it, but we're just gonna call it good. Okay. So PQ is 2, 1, negative 4, and PR is 2, 1, negative 2. Okay. So when you're interested in perpendicular, you do cross multiplication. So I, J, K. So this becomes 2, negative 1, negative 4, 2, 1, negative 2. Let's do calculation. I component will be negative 1, negative 4, 1, negative 2, I minus 2, 2, negative 4, negative 2, J plus 2, negative 1, 2, 1, K. So I component you're interested in this quadrant, J component you're interested in this quadrant and this quadrant, K component you're interested in this quadrant. But when you do the J component, you have to put the negative sign. So this, if you do the calculation, this becomes 2, and then 2 minus 4 I, and then minus 4, and then minus 8 plus 8 J plus 2 minus 2 plus 2K. So this becomes 6I minus 4J, and then plus 4K. So this is 6, negative 4, negative 4, 4. So you can get this answer. Or if you do PR times PQ, you might get negative 4, negative 6, 4, negative 4. Both are the right answer. It's just a different, like, how you found it. Like, it depends on whether you do PQ times PQ cross multiplication of PR or PR times PQ. It doesn't matter. It's just a multiple of 6, negative 4, and 4. So, and if you look at your answer choices, there's no right answer. So I'm going to change D and put 6, negative 4, and 4. And put D as the right answer. Because if you look at the past exam archive, there's no right answer for number 4. So it was an omitted question in that final. But I'm going to change it to 6, negative 4, and 4 for D. So I'm going to make the right answer. So the answer is D. Okay, this question is to find a volume of the solid obtained by revolving the region bounded by y equals e to x over 2 plus 1, y equals x, and x equals 0 and x equals 1 about the y equals 1. Okay, that's a lot of restriction, I guess. Y equals e to the x over 2 plus 1. Okay, so 1 here. And y equals 3, like here, this region, y equals 3, and then x equals 1, like around there. So the region bounded by is this region, and this is revolving around the line y equals 1. So this line, it's revolving around. So I'm more favorite of the disk method, so I'm going to use the disk method. So it's as if you're revolving around y equals 1, this line, it's gonna be vertical, like perpendicular. So it's like looking like this. The shape is looking like this. So the entire bigger radius in our case is this entire line, right? So the length is 2. So bigger radius is 2, and smaller radius is let's see, this line much, right? But the one thing that you have to note is when you calculate the y equals ex, oh, the smaller radius is not that line. Oh, I'm sorry. That is the bigger radius. The smaller radius is this line. If you subtract this line, you will get this line, right? So if you're only interested in this much, which that much, I can redraw it, this much, you have to subtract entire line and then subtract this y equals 1, right? So the smaller radius is a little tricky. So e to the x over 2 plus 1, that is the entire line, right? The entire line is e to the x over 2 plus 1, but we have to subtract y equals 1, this much, to find only this line in between. So e to the x over 2 plus 1 minus 1, which is why it becomes e to the x over 2, which is why it's given as what, like y equals 1, to make your calculation a little simpler. So if you write your equation, b is equal to pi, bigger radius squared, 4 minus smaller radius squared, e to the x over 2 squared dx, and it's from 0 to 1, right? So it's 0 to 1. So it's, I'm gonna move my cursor. So it's pi, 0 to 1, 4 minus e to the x dx. So if you integrate this becomes 4x minus e to the x, pi, entire thing from 0 to 1. So this becomes pi 4 minus e, and then minus plus e to 0. So it's minus, and then minus becomes plus. So this becomes pi 5 minus e. So the answer for this question is A. Okay, this question asks to find a 10-meter chain hangs from a wrench. Oh, it's wrench, it's not wench, okay. And the chain weighs 1.5 kilogram per meter, and find the work. So work is basically the integration of fx dx, and we can find the force equation by multiplying the weight, 1.5 times the gravity, 10, times the distance, which in our case, the distance is changing from 10, right? And the distance is some kind of x, and then the distance is changing from 10 minus x, right? Because it's winding up. So you put the distance as 10 minus x. So distance become, so distance become 10 minus x. So this become 15 times 10 minus x integration. So 15 10 minus x dx, integrating from 0 to 10 because it's winding fully up. So this is 0 to 10, 150 minus 15x dx. This is 150x minus 15x squared over 2 from 0 to 10. So 150 times 10 minus 15 times 10 times 10 over 2. This becomes 1500 minus 750, which is equal to 750 joule. So the answer for this question is B. Okay, this question asks to what is the most appropriate substitution of procedure to compute, and we see that sine to the 6th power and then cosine to the 7th power. So, and we know that usually for the appropriate substitution, you have to choose what is the even power, and we see the even power is the sine. So our substitution will be u equals sine x. So the answer will be B, but I will explain it more. So sine to the 6x times cosine to the 7th x dx, right? So I can separate the cosine to the 7th x as cosine to the 6x times cosine of x dx. And we choose u equals sine x because we can put that one single cosine of x dx as derivative function of u equals sine x. And this, if you put u equals sine x, that cosine x dx will be our du, right? So that's why we put the even power as our u substitution, which is why the answer is B. Okay, this question has to find 0 to 1 x to the e to the 3x dx. Okay, 0 to 1 x to the e to the 3x dx. I'm going to do the limits by, not limits, parts by integration by parts. There we go. So it's a Lyot, logarithmic, inverse trig, algebraic, trig, and exponential. So we see algebraic function and exponential. So, and it's the left to right order. So we see algebraic function first. So that's gonna be our u equals x. Du becomes dx, and then our dv is e to the 3x dx, and then v will be e to the 3x over 3. And the integration by parts, that's ub minus b du integration. So ub is x e to the 3x over x minus e to the 3x over x over 3 dx. So this becomes x e to the 3x over 3 minus, it's from 0 to 1, I forgot that, 0 to 1 e to the 3x over x 3 dx. And you have to put this as 0 to 1 as well. So let's do the calculation as well. So, I mean, you have to do a calculation, but yeah, we're going to start doing calculation. So we plug it in 1, so this becomes e to the 3 over 3 minus 0. Okay, cool. We have that plus 0 for the first integration or calculation. The minus, this becomes e to the 3x over 9, integration from 0 to 1, right? So e to the 3 over 3 minus e to the 3 over 9 minus 1 over 9, right? So this becomes e to the 3 over 3 minus e to the 3 over 9 plus 1 over 9. So this becomes, I'm going to put everything into 9. This becomes 3 e to the 3x minus e to the x, e to the 3 plus 1. So this becomes 2e to the 3 plus 1 over 9. So the answer for the question is B. Okay, this question asks what is the most appropriate substitution to compute. So it's from 0 to pi over 4 secant to the 6 power x dx. I'm going to separate secant to the 6x dx as to secant to the 4th x times secant to the squared x dx. Because I know secant squared x dx has a derivative of, if you derive of tangent, you get secant squared x dx. That's why I'm going to move the secant 4 and secant second. And then we can move the secant to the 4th power x dx, x secant squared x dx as 0 to pi over 4. And remember that the trig identity, tangent squared x plus 1 is the secant squared x. So secant to the 4th x, it will be tangent square x plus 1 squared, right? So this becomes tangent square x plus 1 squared secant squared x dx. And if you have this form, you can put u as tangent to x, right? And then you can find du as a secant squared x dx, and you can change everything in this respect to u. So you can put u as tangent x, which is why the answer for this question is A. Okay, this question is to reduce the integrand to partial fraction decomposition question. I see. So the one thing that you have to note is the numerator term is high. Numerator term has a higher term than the denominator term. The numerator has the cube power and the denominator is a square power. So you divide it first. You can't just do partial fraction decomposition, which is why people might get it wrong at the first hand. So that's a trick. So 2x to the cube plus 1 divided by x squared minus 4x plus 4. This is 2x. 2x cubed minus 8x squared plus 8x. This becomes 8x squared plus 8x plus 1. So plus 8. 8x squared minus 32x plus 32. This becomes 40, right? X. Did I do this right? Oh, I actually, yeah, 8x squared minus 8x. A minus 8x plus 1. Sorry, I have to change the sign because you subtract this thing. So this becomes negative 8x squared negative 8x. Which is why this part becomes so this canceled out, so this is going to be 24x minus 31. Sorry, I messed up my calculation. So if you look at your option, 2x plus 8 is only b and e, so ACD is not right. So let's look at our option. So if you write it as then 2x plus 8 plus 24x minus 31 over x squared minus 4x plus 4. Okay, we have that. And then 2x plus 8 plus, if you look at the denominator, it's x squared minus 4x plus 4, which is x minus 2 squared, completing the square. So if you write the partial fraction decomposition form, you have to write a over x minus 2 first, and then do the squared, x minus 2 squared, and then it's just the constant b as well. It's just constant a in the a over x minus 2 because the highest power is 1, and we do the subtraction of 1 power from denominator power, which is why it's a 0 power, and 0 power is just a constant, which is why you put a. And then if you have the squared value, you don't put the bx plus c, you do b because it's the same value squared. It's just a rule of partial fraction decomposition. So since it's x minus 2 squared, you follow the same like it's not same number but like same power as the first one, which was x minus 2, which is constant. So you do the same powers, so power is 0, so the constant b comes there, which is why the answer for this question is E. Okay, this question has to compute that thing. Okay, so 1 over x squared, 4x squared plus 1 dx. And we can write this as square root of 4x squared plus 1. Now we can write this as, well, like, since I see the square root and then 4x squared plus 1, I'm going to use the trig substitution. So 4x squared plus 1 goes to the hypotenuse, and this becomes 1 and 2x. So this is going to be the theta. So it's going to be the tangent theta is equal to 2x. That would be the easiest form to do it. And then tangent theta over 2 is x. So dx becomes secant squared theta over 2 d theta. Cool. We have that. And then let's do the 4x squared plus 1 now, right? So 4x squared. So 4x squared is equal to tangent squared theta, d theta. So 4x squared plus 1 is tangent, not d theta, tangent squared theta. And the 4x squared plus 1 is tangent squared theta plus 1. So, and then the x squared itself is going to be tangent squared theta over 4. So we can write everything as 1 over tangent squared theta over 4 square root of tangent squared theta plus 1 times secant squared theta over, or just, I'm going to move that, and then times secant squared theta over 2 d theta. So if you remember your trig identity, tangent squared theta plus 1 is secant squared theta, right? So if you do the square root, this becomes 1 over tangent squared theta over 4 times secant theta times secant squared theta over 2 d theta. Secant and secant squared can be reduced, so this becomes secant theta over 2 d theta, 1 over tangent squared theta over 4 times. So this becomes 4 over tangent squared theta times secant theta over 2 d theta, which can be reduced into 2. So this becomes 2 secant theta over tangent squared theta d theta. This is a lot of calculation, right? We love it. Okay, and we know that tangent theta is same as sine over cosine, but it's 1 over tangent squared. And okay, let's go for tangent squared first. Tangent squared is same as sine squared theta over cosine squared theta, and it's asking 1 over tangent squared theta. This is just swapping the denominator and nominator. So this becomes cosine squared theta over sine squared theta. So this becomes 2 secant theta times cosine squared theta over sine squared theta. And 2 secant theta is same as 1 over cosine theta, so this becomes 2 over cosine theta. So this can be reduced into 2 cosine theta over sine squared theta d theta. And we can do u sub now, right? Because we know that sine theta derivative is cosine theta, right? So you can put u as sine theta, du as cosine theta d theta. So this becomes 2u squared. 2, not u, du over u squared. So this becomes 2u minus 2 du. This is 2u minus 1 minus, so this is right, plus c. And we know that it's u is sine theta, so this becomes negative 2 over sine theta plus c. And if you recall, our original sine theta would be from this triangle thing, which I can draw it again in here, which was 1, 2x, square root of 4x squared plus 1, and theta, you have to write things in x now. So sine theta was 2x over square root of 4x squared plus 1, right? So since it's 1 over sine theta, this is gonna be square root of 4x squared plus 1 over 2x. So this becomes negative 2 times 2x square root of 4x squared plus 1 plus c. So this is negative x square square root of 4x squared plus 1 over x plus c, which is, oh wow, b. So the answer for this question is b. Okay, this question asks to compute x to the cube over square root of x squared minus 2x plus 2. So, okay, this is the trig sub as well. So it's from 0 to 1, x cubed over dx, and then x squared minus 2x plus 2, which you can write x squared minus 2x plus 2 as the completing the square form. So it's going to be x minus 1 squared, which will be x squared minus 2x plus 1, right? And then you have to add something to make it into the x squared minus 2x plus 2, which is adding 1, right? So you add 1. So this is square root of x minus 1 squared plus 1. Okay, so we have that. So if you draw our triangle, the theta, square root of x squared, x minus, this part is x minus 1 squared plus 1, and then this is going to be x minus 1, and this is 1. So it's going to be the same tangent theta. The tangent theta is equal to x minus 1. Okay, we have that. And then x minus 1 squared, that's what we are interested in. So it's going to be tangent squared theta is x minus 1 squared. So this thing will be tangent squared theta plus 1. And then let's find the dx now. Okay, let's find the x first. So x is going to be tangent theta plus 1, right? So x cubed will be tangent theta plus 1 to the cube power, tangent theta, it's t that we're interested in. I see. Okay, we'll change everything theta into t now, because I just noticed that we're interested in tangent t. Everything is with respect to t, so I will change everything into t. Sorry about that. So tangent t plus 1. Okay, so this becomes tangent t plus 1 cubed, and then the under is tangent squared t plus 1, because tangent t is x minus 1, which is tangent squared t, and then plus 1, and that's the denominator part. So which is why tangent squared t plus 1, right? And since we have x, we're going to find the dx as well. Dx will be just secant squared t, right? This is just secant squared t dt. And the bound, we have to find it, right? So x is tangent t plus 1, and then we are going to find the bound of t. So we are going to solve it for t. So t will be tangent inverse of x minus 1, and it's integrating from 0 to 1, So if it's x equals 1, plug it in. T equals tangent inverse of 0, which is 0. X equals 0. T equals tangent inverse of -1, which is negative pi over 4. So the bound is from negative pi over 4 to 0. Okay, since so far we have this, so technically we could cancel out almost all the options, right? Since this bound is from negative pi over 4 to 0, it's not going to be A, D, E. It's going to be either B or C. And since we know that it's 1 plus tangent t to the cube power, so it's going to be automatically C. But we're going to continue our calculation. The tangent squared t plus 1, if you remember your trig identity from the previous question, tangent squared t plus 1 is same as secant squared t. And this is square root, so this becomes negative pi over 4 to 0. Tangent t plus 1 cube over square root of secant squared t times secant squared t dt. So this is 0 to negative pi over 4. Tangent t plus 1 cube over secant t times secant squared t dt. Cancel, reduced. 0, negative pi over 4, tangent t plus 1 cube secant t dt. So the answer is exactly matching to our answer choice C. So the answer is C. Okay, this question asks to integrate that thing. Okay, cool. So it's from 1 to infinity, if I can write it. 3t plus 1, my letter is overheating, I see. 3t plus 1 over t squared dt. Okay, I'm going to separate this into two. So 1 to infinity, 3t over t squared plus 1 over t squared and dt. Okay. Okay, so, right. So I can separate this into 1 over infinity, 3t over t squared dt plus 1 over infinity, 1 over t squared dt. Okay, we have that. And this can be written, the first one can be written as 1 over infinity, 3 over t dt plus 1 over infinity, t minus 2 dt, right? So 3 over t dt is same as 3 ln of t integrated from 1 to infinity, and then this will be plus negative t minus 1 integrated from 1 to infinity. So plug it in, 3 ln of infinity minus 3 ln of 1 minus t minus infinity minus 1 plus 1, right? So 3 ln infinity is just infinity, right? This is 0, this becomes 0. So plus 0, and then this is going to be plus 1, and then this is negative infinity, negative 1, which is same as negative 1 over infinity, which is 0. This just goes away, and then infinity plus some kind of like a constant number, it's just infinity. So the integral actually diverges, so the answer is E.